Okay, so in this section of integration, we are using trigo proving. We are using trigo proving to integrate. Okay, so we are making use of the trigo formula to integrate. So, okay, I show you the idea first. It's quite difficult because in the first place, right, there is a trigo showing here. Okay, so for 6 part 1, usually most people will find it difficult to show. So part 1 is the trigo proving. So in this part 1, okay, I would like you to try, but my hint is you need to use double angle formula. So you need to expand the left side. Okay, the hint is you start from the left side, you do your basic expansion. You use this expansion, and then you got to be using double angle. So the double angle will be this one. The double angle is provided during exam. Okay, so you got to stare at the double angle. Okay, particularly you're going to stare at this one. You stare at this one, and you make cosine square the subject. So you make cosine square the subject. So this is the formula for cosine square. So I'm giving you the hint first, then you can try the proving. Okay, another one that you need to stare at will be cosine 2x equal to 1 minus 2 sine square. And you are making sine square the subject. So you will see that sine square has a huge fraction as well. So this will be the hint to help you to do your proving. Okay, so let's say you couldn't prove. Okay, so we just go on to the hence part. So if let's say in exam you try the proving and it doesn't work, or you don't even have much time to try the proving, you take it first. So what do we mean we take it? We take it as this is a formula. So this whole thing is equivalent to this whole thing. So we just take it as they are equivalent. So I'm gonna make use of this trigo formula to help me to integrate. But when I try to integrate part 2, okay, I want you to realize something. So I want you to realize something. You look at the bracket in part 2. The bracket in part 2 looks a little bit different. Do you realize that the position swap? So I need to have an idea. How is this bracket related to the first formula? So you need to think, you need to be able to do some algebra. So you need to be able to think, like maybe I factorize out a negative. So if I factorize out a negative, okay, so I'm factorizing out the negative within the square. And then the negative is like a -1. So I'm going to square the -1. And I'm going to square the bracket. And squaring -1 actually gave me a 1. So you will realize that this is actually equivalent to, okay, that means this part is equivalent to this part. So after some algebra manipulation, you realize that they are the same. And therefore, if you are asked to integrate this, that is as good as integrating, is equivalent to integrating this. And because they are equivalent, then I can use the whole formula that I manage to prove or I don't manage to prove in the first part. And because I replace it like this, I have 3 integration that I can do. So I can integrate a constant. I can integrate a sine 2x, and I can integrate a cosine 2x. So integrating a constant, you should know by now, you will get a 5 over 2x. Integrating a sine 2x, that is in your basic trigo integration formula. So you will get minus 1 over 2 cosine 2x. Integrating cosine, you will have a 1 over 2 sine 2x. So that everything is integrated. So you reduce it to something that you have some formula to integrate, or else you actually couldn't integrate. So this part of the integration is actually quite difficult because there's a proving also. Okay, so this one doesn't have the reverse because proving is like a formula. So you change the whole expression with the formula. But there are some times where it's actually differentiate trigo equal to another trigo. So if you differentiate a trigo equal to another trigo, then you got to do the undifferentiate idea. Okay, so in this case, right, this is a trigo identity. So we do not need to reverse it. But if you differentiate a trigo to get another trigo, then you need to do the reverse part. Okay, so I'm not showing it here. The emphasis is actually on trigo identity. Okay, so the next one is also a proving. This proving is a little bit, it's not that difficult, but I think I will give you the hint for the proving first. So for this one, right, you start from the left side. This is a huge fraction. Okay, so I will see it as a numerator divided by a denominator. So you got to get your basic formula. So that is the hint. I will not continue to show all, but here, because they are already same denominator, you got a single fraction. If you can divide by a single fraction, you can change it to a multiply. Flip. Okay, so after that, I let you continue. Okay, so the hint will be you will be using one of the basic formula. So you give it a try. So again, if let's say you didn't manage to prove, or time is running out, you look at the whole thing as a formula. So this is the equivalent formula. So with the equivalent formula, I'm trying to integrate this thing that they wanted. So the difference between this and the formula is there is a number 2. There is a constant 2 that I can actually just bring it up. So once I bring out the constant 2, the huge fraction is equivalent to 1 plus cosine x. So the whole fraction is equivalent to 1 plus cosine x, which is very, very easy to integrate. So if you integrate a constant, that's a x. Integrate a cosine x, that's a sine x. So that is just your final answer. So this part is actually quite easy if you just take the whole formula. So you will usually lead you back to all the basic formula. So in the first place, your basic formula must be okay, or else you find that every step in this type of question is a huge process, or rather you get stuck every single step. Okay, so this is another type. This is a trigo identity. So let me repeat first. If this is a trigo identity, that means it's trigo proving, you are changing the formula. So you change it out, you see it as a formula. But if it's differentiate trigo equal to trigo, then you got to do the undifferentiate it. Like part A, you got to undifferentiate it, which you need to reverse it. Okay, so that falls under part A. But here, trigo identities means it's just the same formula. Okay, so don't get confused during exam. Sometimes some students will get tricked.